اسمي يوسف وادي من فريق OaSysInterop. Hi, my name is Yusuf Wadi from OaSys team from Jordan.
So what is Project OaSys all about? Project OaSys is going to help people try to track and monitor drought and dryness of land. This will help us stop desertification before it starts. So if we have a good overview about desertification and we have an analysis and trend, we can stop desertification before it occurs. So we will be using maps to represent drought over the world, as well as the sensors that are spread around the world to stop drought. So our system has a lot of interoperability in it. As you can see, since we're using our map systems and we can export to other maps, we also want to be able to export our data into PowerPoint, Excel, and even let other systems use it. So we're using open data. Open data helps us have JSON, XML, and other formats, Atom RSS for example. And by doing that, we have a fully integrated system with other systems. And now we're turning OaSys into a platform. So let's take you to the demo and let you see how it all works.
Hello. Now, since you have a good overview of the project, we're going to show you how the interoperability of our system works. Now, we already created a system where you can see the readings of the land. Now, if you see here, we have boards spread around Jordan. So let's zoom into Jordan and see the boards. You can see that we have two reference boards. One is the bad, one is the good. This is in the desert region. This is in a good area. And these two are the land that we want to make sure that do not go through desertification. So if we click on one of the boards, you can see the sensor readings on the right. You can also go to analysis charts, where you can see that they chart out the analysis readings over time. And you can also switch to table to see the table view. You can also filter by date using the date picker on the right. Now if we return back to the map, you can see there's trends on top. If you go to trends, you can see how the land is acting over time. So you can see here is a positivity in desertification, so it's getting worse over time. Now, if you click on it, you can go to predict. And if you click predict over 1 year, for example, you could use any other day or anything, but you can use 1 year now and say predict, it will tell you it will be a 79% in 1 year. So, where's our interoperability? Here we go. The first thing is that you could load external plugins into our system and you let the people use these plugins. So, let's say you want to create an RSS feed about some areas that have problems in it. For example, drought. We go to load external plugins and then you place the URL of your plugin that you have built. We already built one. We just say OK. You can see on the right, on the top left, we have a new tab called Test One, which we called our plugin a Test One. Clicking on it, it shows you RSS icons. You click on RSS icon, you can see the data that is supposed to be here. So that's number one in our interoperability. Now, let's say you don't want to use this interface, but you still want to harvest the data that is in our system. So let's say that we go to the GeoRSS website. We call it the GeoRSS because it generates GeoRSS, which is a W3 standard for maps, and KMZ files, which is also for desktop maps. Let's say we want to see the GeoRSS for data. Clicking on it will give you an XML feed, as you can see right here. Now, let's say we want the data KMZ. This gives us the sensor data. So I just opened it, and it opens the default map system, which is Google Earth. As soon as it opens, it will zoom in by itself to the boards, and here you go. You can push on a board and it gives you all the readings for the sensors for every board. Now you can send this file to any of your friends that don't even want to access the system, or even just want to have a file for recording. Now, if we go back to analysis KMZ, it will show you the analysis of the land over time. So we can choose, it will give you the last date, or you can specify a date in the query string, where you can see right now we're generating the map with the icons on it. The orange says that the land is in the middle. That means it's around 46% desertification, whereas the green wasn't still safe at 10%. Now, that's the first part. Now, we're using web services here, but we also implemented open data. Open data will allow our system to create an amazing exposure of our data to people. So, open data, for example, can extract JSON, Atom RSS, and others, a lot of other standards. Now, using open data, we can show you how it works, for example, with Power Pivot. So we already created an open data link. We're just going to copy this link and go to Excel. As soon as we log into Excel, we go to Power Pivot, where it's Excel 2010 supports Power Pivot. So if you go to Power Pivot, and you can say Power Pivot window, and you can say load from data feeds. It asks you for the URL. We're going to give it the URL. Now, it returned back what you can view. Let's say we want to see the analysis readings. It will return to you a very large list of analysis readings that you can use. You can start using it to model data, to do whatever you need on it. Okay, this is another point of interoperability. Now, the team is implementing an SDK for the system so that everyone can start developing for our system and we can develop a global partnership.
Since our system requires a lot of computational power, we have taken the project and placed it on Windows Azure. Windows Azure now allows us to expand our system as much as we need and will give us as much computational power as we need.
As we are aiming for a global partnership where everyone uses the system, the calculations can really become a great obstacle, especially with a huge number of readings. So to solve that, we thought about cloud computing, which is certainly a viable solution, where the cloud manages the resources as needed, whether to expand or use limited resources. It's the cloud's ability to do that. So with Windows Azure and SQL Azure, it's certainly a good solution. And now I'll show you an example of how to use of the cloud, how Project OaSys is cloud enabled. So if you start Visual Studio with administrator options, and we open the project that we've done. Here in this project we have written all the code that we needed for the calculations, and if we run it, it's gonna start the Azure service, the worker role, and this is the fabric, the development fabric. As you can see, it's starting up now. It takes a few seconds. Now the development storage has started. Now we're waiting for the fabric UI. Yep, now it has started. Now I'm just starting the console for the Azure, the trace. As you see, the code is in the worker role. Now I have this worker role where we have one process for the cloud. If we click on it, it can expand. Now you can see here, as the trace has written, it finished calculating the analysis values, and this is the trans values. It has calculated them for today. Now it's standing by for the next values, for the next timer to run and calculate the necessary values.